Hello everyone. Today we'll be looking at some quick solutions of All India AAKAS Test Series JEE Advanced 2019 Test 3A Paper 2 Code C and D. So let's start with the first section. This section contains 9 questions. Each question has 4 options, out of which only one single option is correct. So let's start with question number 21. Consider the following reaction sequence. So we have been given a beta keto ester and we have been given a list of reagents, and we have to select the incorrect statement about the major product P. So let's try and figure out what this product P is. So if we look at the sodium methoxide which is given to us, so this methoxide ion can attack this carbonyl carbon and give a substitution reaction, but that will lead to the formation of the same product. Hence, we need not worry about the transesterification. Next, this sodium methoxide will extract the acidic hydrogen present on the active methylene group here. So we can see that this group is active methylene group and the hydrogen attached to it will be acidic. So this sodium methoxide will go and extract an alpha hydrogen and create a carbon ion here. So we'll have this structure. The carbon ion will be generated at this position. Okay. So now next, the reagent added is CH3I. So students, this carbon ion will do an SN2 reaction on CH3I and make this I minus leave. So we'll have EtCO CHCH3 and we'll have COOMe. In the next step, the examiner is interested in the hydrolysis followed by heating. So if we talk about the hydrolysis first, so this ester will get converted into acid. So we'll have EtCO CHCH3 and we'll have COOH. Okay. Now this structure is a beta keto acid, and when we heat a beta keto acid, it undergoes loss of a CO2 molecule. So this CO2 molecule will leave. There will be decarboxylation in the structure and we will get this structure. So this is a ketone. So if you look at the options now, we had already seen that we have to select the incorrect statement. So if you look at the A statement, P gives positive iodoform test. Students, iodoform test is given by methyl ketones. So this structure does not contain a methyl keto group. So this will not respond to iodoform test. So this statement is incorrect. If you look at the B option now, P gives 2,4-DNP test. This statement is correct. 2,4-DNP test is generally given by aldehydes and ketones. Let's look at option C. P on reduction with LiLH4 and ether can produce a secondary alcohol. This statement is correct, students. If it is allowed to react with LiLH4, we'll call it LAH, in ether, we'll have the formation of a secondary alcohol. So the C statement is also correct. Let us look at statement D. P contain a ketone group. This statement is correct, students. We can see that the product P contains a ketone group. So in this question, since we have to select the incorrect statement, so the answer which we have to mark for this question is option A. Moving on ahead to the next question. Question number 22. 4 compounds are given with their pKa value. So we have been given acetone, ethyl acetate, ethyl acetoacetate and diethyl malonate. So the structure of diethyl malonate is given to us. We can talk about the other compounds as well. So we have acetone. We have ethyl acetate. So this is the structure of ethyl acetate. We have ethyl acetoacetate. So the pKa of this compound is represented by P, of the second by Q, of the third by R, and the structure which is already given to us, the pKa value of that is represented by S. So let us now try and compare these. So if we talk about the acidic strength, so we know that the compounds third and fourth, they contain the active methylene group. So these active methylene groups are more acidic than the normal alpha hydrogen of carbonyl compounds or carboxylic acid and the derivatives. So we can see that the acidic compound of the third and the fourth compound will be greater than the first and the second compound. So we can have 3, 4 greater than 1 and 2. So now if we compare between 3 and 4, if we talk about the acidic order, we have to comment on the stability of the conjugate base. So if we try and generate the conjugate bases, so we can see that the conjugate base which is created in the third structure is more stabilized because there is only one ester group present, and in this case we have both the groups present as ester groups. So these ester groups, due to their cross conjugation, will lead to a lesser stabilization of the carbon ion produced as compared to a ketone. Okay, so we can see that the structure 3 is more acidic than the structure 4. Now if you look at the first and the second structure, let's first try to generate the carbon ion. So now if we compare the resonance stabilization of these two carbon ions, there will be a cross conjugation in the second structure because of the lone pairs over oxygen. So this will lead to a lesser stabilization as compared to the first structure. So we can have the acidic strength as 3 is more than 4 is more than 1 is more than 2. So if we talk about the pK values, the pK values will follow the reverse order. So the pK of 3, which is represented by R, will be the least, followed by S, followed by P, and followed by Q. We can see that the correct option is given in option B. So students, the correct answer to question number 22 is option B. Let us look at question number 23 now. In a container, pure isomer of compound A is present. So we have a pure isomer. If a small amount of acid or base is added in this pure isomer, then after some time the solution contains. So we have been given the structure of A. So the examiner seems to be interested in knowing if the solution contains only R, only S, both R and S, or neither R nor S isomer of A. So if we have a look at the compound A which is given to us, so we have been given a cyclic ketone, okay, and this cyclic ketone has only one alpha hydrogen. So students, we know that ketones can undergo the formation of enol in the presence of an acidic or a basic medium. So if we talk about the product which is formed in the presence of acidic or basic medium, we'll have the enol, represented by this structure. Okay. So students, we know that these ketone-enol forms are always in equilibrium. Now, when the enol form will revert back to the keto form, so we can have two options now since this is a planar species. So we can either revert back to this structure, or we can have the formation of another structure in which the hydrogen, which was initially in the wedge position, can now be in the dashed position. So we'll have a hydrogen in the dashed position and we'll have the methyl in the wedge position now. Whereas on the other alpha carbon, the stereochemistry is not of much importance as both the groups are same. So students, with the passage of time, due to the formation of the enol, which is catalyzed in the acidic or the basic medium, we can have the formation of another isomer of the compound A which was given to us. So if we look at the structure of the compound A and the other compound which is present, so we can see that both of these are enantiomers of each other. So the solution which had only a particular isomer of A now has its enantiomer also. So we'll have both the R and the S isomer. We need not find out the configuration because it is of not much importance. Okay. So students, we have to mark option C as the correct answer to our question. Let us look at question number 24 now. Phosgene is a toxic and a corrosive gas, and its use as a reactant is inconvenient. Several phosgene derivatives like N, O and P have been developed, which are given below. So we have phosgene, which is represented by M. We have substituted the chlorine atoms by some other groups to form compounds which are derivatives of phosgene. Okay. So the examiner is interested in knowing about the compound which shows the highest reactivity towards nucleophilic attack in nucleophilic acyl substitution reaction. So students, the examiner is interested in knowing about the nucleophile which is going to attack at the acyl carbon, which is represented by the arrow. So students, we know that the nucleophilic attack will depend on the leaving group ability. So if we compare the leaving groups, Cl minus over here, we'll have the substitution of a para-nitrophenoxide ion over here. We'll have the substitution of a phenoxide ion over here. And in the last case, we'll have the substitution of a methoxide ion. So if we compare the leaving group abilities, we can probably have a look at their conjugate acids, and the acid which has greater acidity will have its conjugate as a better leaving group. So we know that HCl will be the most acidic among all the acids formed. So Cl minus will be the best leaving group among these. Next we'll have the para-nitrophenoxide ion, in which the negative charge on oxygen will be stabilized by the minus M, which is exerted by the nitro group, followed by the phenoxide ion, which is again resonance stabilized as compared to methoxide ion. So in the question, the examiner is interested in knowing about the best leaving group. So we have to mark Phosgene as the correct answer to our question. So the correct answer to question number 24 will be option A. Moving on ahead to the next question. Let us look at question number 25 now. A student synthesized compound P. So we have been given the structure of P. To purify the compound P, he extracted it into an aqueous base and then acidified the solution, followed by heating. So he found out that his product P had been converted into another compound Q, which is given below. So if you look at the options, the examiner seems to be interested in knowing about what reagent catalyzed this conversion. Okay. So the examiner is interested in knowing whether the above conversion happened by the addition of acid or the addition of base. Students, if we look at the compound P which is given to us, so this structure is an acetal. So we know that acetals are stable in the basic medium. They do not get hydrolyzed in the basic medium. So when this compound P was extracted into aqueous base, what must have happened was that the basic medium would have extracted this proton which is present at the carboxylic acid. Okay. So P, when it was subjected to basic medium, we would have gotten the structure. And now when it is subjected to acidification further. So now this acidification is going to do two things. Firstly, it is going to protonate this carboxylate ion which was present there. And also it is going to hydrolyze the acetal which was formed. So it is going to regenerate this carbonyl compound and the dialcohol which was present. So we are going to have the formation of CH3CHO, which was the carbonyl, which will be generated from here, and it will lead to the generation of the diol. So we'll have the diol as this structure. Now students, this diol, when it is subjected to acidic medium in presence of heating, it can lead to intramolecular esterification, which will lead to the formation of a cyclic ester. So we can probably try and figure out the number of species which will be present in the cyclic ester. So we're going to have 1, 2, 3, 4, 5 and 6. So students, it is going to lead to the formation of a 6-membered ester, and we know that 6-membered rings are very stable. This is going to produce a 6-membered ester. We have already labeled the species present. So the oxygen is labeled as 1. So then we can start just labeling 3, 4, 5 and 6. So we can see that there will be a carbonyl group present at carbon number 6. So this is the carbonyl group present at carbon number 6. And at the 4th carbon we have a methyl and a hydroxy group. So we'll have a methyl and a hydroxy group. So if we try and compare the structure which is formed due to the acid catalyzed hydrolysis in the beginning and then the intramolecular esterification, we can see that the product which we have obtained is the same as the product Q mentioned to us. So students, if we look at the options very carefully, we can see that the correct statement is given in option B, in which P is converted into Q because the student added the acid and P is not very stable in the acidic medium. So students, we have to mark option B as the correct answer to our question. Let us look at question number 26 now. When pure S-lactic acid is esterified by a racemic 2-butanol, the product is 2-butyl lactate according to the below reaction. So we have been given a reaction in which the pure S isomer of lactic acid is allowed to react with a racemic mixture of 2-butanol. So the examiner has told us that 2 isomer of butyl lactate is formed. Select the correct statement. So if we try and figure out the product which will be formed, we know that the esterification reaction takes place between the carboxylic acid and the alcohol group. So if we look at the chiral carbons very carefully, we can see that the chiral carbon is not taking part in any sort of reaction. So the configuration will be retained in the product as well, since it was S or the minus isomer. So the product will also contain this group in an S form, provided the priority of other groups has not changed. Okay. And if we talk about the butanol, so it is going to have a racemic mixture. So the product is going to contain both R as well as S isomer. So if we try and figure out the configurations of the 2 chiral carbons which will be present in 2-butyl lactate, we can see that the configuration will be S, R and SS. So the chiral carbon of butanol can have both configuration R as well as S, whereas the chiral carbon of the lactic acid is only going to appear in the S form only. So if we try and compare these two stereoisomers, we can clearly see that these are diastereomers. So if we look at the options now, option A says 2 isomer of 2-butyl lactate are enantiomer. It is incorrect. They are diastereomers. In the second statement also, the examiner has called these isomers as enantiomers. This is also incorrect. Let us look at the C option now. 2 isomer are diastereomer, in which configuration of chiral carbon of lactic acid remain S in 2-butyl lactate. So students, this statement is correct. If you look at option D now, 2 isomers of 2-butyl lactate are diastereomers, in which the configuration of the chiral carbon of 2-butanol is R. So the configuration of chiral carbon of 2-butanol can be both R as well as S. So this statement is incorrect. So students, we have to mark option C as the correct answer to question number 26. Let us look at question number 27 now. So in this question, we have a cyclic amine which is first allowed to react with CH3I and then it is allowed to react with Ag2O heat. So students, we can clearly see that the examiner is interested in talking about the Hoffmans methylation and Hoffmans elimination. So in the first step, this lone pairs over nitrogen will make an SN2 attack on the CH3I, causing the I- to leave. So which will lead to the formation of a quaternary ammonium salt. So the nitrogen is going to have a positive charge. Now in the next step, when it is allowed to react with Ag2O heat. So this Ag2O heat, it causes Hoffmans elimination. In which the least hindered hydrogen is extracted. So if we look at the beta hydrogens present over here, we have a beta hydrogen at this position, we have a beta hydrogen at this position, and we also have a beta hydrogen at this position. So we can see that out of all these hydrogens, Ag2O will extract this hydrogen and this bond will shift at this position, causing this bond to become lone pairs over nitrogen. So if we try and draw the structure of the product which will be formed, we'll have an alkene at this position, CH2, we'll have a methyl branching at this position, and we'll have a tertiary amine. So this is the structure of the alkene which is formed. Now students, this alkene is subjected to oxymercuration, demercuration. And we know that after oxymercuration, demercuration, the product form is Markovnikov addition product without the rearrangement of a carbocation. So students, if you look at these alkene, the hydroxy group will be attached at this position. So which will lead to the formation of the structure which is depicted now. So if we try and look at the structures very carefully, we can see that the correct option to this question is option A. Let us move ahead to the next question. Question number 28. An optically active compound A has the molecular formula C6H10. So C6H10 has 2 degrees of unsaturation. Compound A contain no triple bond. A on catalytic hydrogenation form optically inactive compound B, and B is an open chain compound. Select the correct statement about the compound B. Okay. So in this type of questions, it is generally good practice to find out the degree of unsaturation first. So we have a DU of 2. Now it is mentioned to us that the compound contains no triple bond. So the other options which is left to us is either 2 alkenes or a ring and an alkene. It has also been made clear to us that the compound A does not contain any ring, as the compound B is an open chain compound. So this must be a diene. So if we talk about the diene, it has to be optically active. So we can have 2 carbons on this side, we can have 1 carbon on this side, we can have an hydrogen on this, and 2 further carbons are left to us. Now if we try and make this alkene as optically active, it will not be possible. So the next option is to look for a cumulative diene or an allene. So if we try and form an allene, we have 3 carbon atoms left. So we can probably add a methyl at this side, and we can probably add a ethyl at this side. And for optical activity, the group present with methyl should not be identical. So we can have a hydrogen over here. And the group present along with ethyl at the same carbon should also be not equal to ethyl. So we can have another hydrogen over here. So students, in this compound, these 2 groups are not same, whereas these 2 groups are also not same. So this is going to be optically active. So this might be our compound A. So when this compound A is subjected to catalytic hydrogenation, we are going to have normal hexane. Okay. So let us now look at the options. Boiling point of B is less than isohexane. Isohexane is more branched than normal hexane. So we know that branching decreases the boiling point. So this is incorrect. The boiling point of N-hexane will be greater than isohexane. If you look at option B now, on monochlorination of B, it produces 3 structural isomers, out of which 2 isomer has 1 chiral carbon each. So we have to draw the structure of N-hexane. So we'll have a 6-membered skeleton. And if we talk about the different monochloro products that can be obtained upon chlorination of this compound, we can have 3 different positions at which the chlorine can attack. So out of these 3 positions, if we look very carefully, we can see that the terminal carbon is not going to produce a chiral carbon. So this will not produce a chiral carbon. If you look at the second position, if an H here is replaced by Cl, we are going to have all 4 groups different on this structure. So this will be generating a chiral carbon when this carbon is chlorinated. And if we look at the third carbon, this carbon will also be chiral when one of the hydrogen is replaced by chlorine, because the propyl and the ethyl groups present are different already. So carbon number 3 is also going to generate a chiral carbon. So we have 3 positional isomers or 3 structural isomers, out of which chlorination at position 1 will not lead to formation of chiral carbon, whereas chlorination at carbon number 2 and carbon number 3 will lead to the formation of chiral carbon. So statement B is correct. If you look at option C now, on monochlorination of B, it produces 5 structural isomers. It is incorrect. We have only 3 different positions. So only 3 monochloro derivatives will be obtained. If you look at option D now, hexane 2-on on reduction with NaBH4 ethanol forms compound B. So hexane 2-on, when it is subjected to reduction with sodium borohydride, it is going to generate an alcohol and not an alkane. So this statement is also incorrect. So students, we have to mark option B as the correct answer to question number 28. Let us look at the last question in this section, question number 29. Consider the following reaction. So we have been given two reactions in which the substrates are allowed to react with H2SO4H2O. They are subjected to hydrolysis with sulfuric acid. So we have to select the correct statement, and the examiner is interested in knowing about the products P and Q and whether or not they respond to neutral FeCl3 test. Okay. So let us look at the first reaction now. The first reaction, we have this structure which is subjected to acidic hydrolysis. So what will happen is the H plus will go and protonate this lone pairs of oxygen, which will lead to the formation of an oxonium ion. Okay. Now in order to stabilize this oxonium ion, one of these two pi bonds will shift. So this will lead to the formation of this structure. Now we have the possibility of ring expansion. So we can have an expansion from 5-membered ring to 6-membered ring. So this will lead to the formation of this. And the carbocation will be generated here due to migration of the alkyl group. Now there will be a loss of proton in order to make this compound aromatic. So the hydrogen from this position will be deprotonated, which will lead to the generation of a double bond at this position. There was a conjugated system initially as well. So we have aromatization in this compound. So this is our product P. If you look at the product formed in the second reaction, that is the product Q, we can have a similar type of mechanism. The lone pairs of oxygen will attack the H plus, leading to the formation of an oxonium ion. Now due to formation of this oxonium ion, the bond from any of these two positions will shift, which will lead to the generation of a carbocation. Now this carbocation will undergo resonance to become a better carbocation, as there will be extended conjugation in the system. And this carbocation will further undergo 1,2 hydride shift to come near the lone pairs of oxygen, as it will lead to a completion of octet of all the concerned species. And now students, the lone pairs of oxygen will stabilize this, leading to the formation of a ketone. And this ketone can now convert to its enol form, leading to further aromatization of the compound. Okay. So these are our structures P and Q. Now the examiner is interested in knowing about the reaction with neutral FeCl3. So we can see that both this P and Q will lead to the formation of a pink or purple or violet coloration with the neutral FeCl3. So if you look at the options very carefully, we have to mark option C as the correct answer to our question.